Hello, hello students. I'm your tutor for today's class. I welcome you all to the Just Tutor platform. And in today's class, we will be continuing our topic of class 9 number system. And in today's class, we will be covering these three topics, which are operations on real number, rationalizing real numbers, and law of exponent. So, are you all excited to learn about these three subtopics, which we are continuing from our last lecture? So, let's get started. First, let's start the operation on real numbers. Basically, you have learned in your earlier classes that rational numbers satisfy some properties, which are the commutative properties, associative property, multiplicative or addition property, laws of addition, laws of multiplication, right? So if we add, subtract, multiply, or divide two rational numbers, we still get a rational number. That is, again, a rational number is a closed. It is closed with respect to addition, subtraction, multiplication, and division. Now, it turns out that irrational number also satisfy the commutative, associative, and distributive laws of addition and multiplication, and the sum, difference, quotient, and product of irrational number are not always irrational. So, they are not closed. Okay. Let's say we have an example. We are going to add root 6 with minus root 6. Okay. If we add root 6 to minus root 6, what is the outcome? What we will be getting is only a 0, because these two are same numbers with opposite sign, and if we add these two numbers, same numbers with opposite sign, we will definitely get a 0. So we can see from here that root 6 was an irrational number, but 0 is not an irrational number, right? Again, we can have example like root 2 minus root 2. Is it? Also, these are the examples of addition and subtraction. If we multiply an irrational number with an irrational number, let's say if we multiply root 3 again with root 3, what we will be getting is we will get just 3, right? Where again we can see that root 3 is an irrational number, but the outcome we got is 3, which is not an irrational number but a rational number, right? Also, in case of division, we can see if we divide root 3 by a root 3 again, these both are same, numerator and denominator get cancelled, and we will get 1, which is not an irrational number, right? So we have seen here the examples of addition, subtraction, multiplication and division of irrational number with an irrational number and getting a rational number as an outcome, right? Let's look at what happens when we add and multiply a rational number with an irrational number. Let's move to our next page and we will see from here if we add or multiply a rational number with another irrational number, what we will be getting. Let's say we have an irrational number 3, root 3, and we add this irrational number with a rational number 2. Can we add these two numbers? We will get outcome as 2 plus root 3, right? 2 plus root 3. Now what about this 2 plus root 3? We can see we already learnt in our last class that these numbers, this number root 3 is non-terminating and non-recurring decimal expansion, right? So since 2 is added with this irrational number, the whole number we are getting is an irrational number. Right? So these are the two cases where we got that it is not always true that when we add, multiply, subtract or divide an irrational number, we are again getting an irrational number. We seen in our this page that we added irrational number with irrational number, subtracted, divided and multiplied, and we got rational number as outcome. And when we added irrational number with another rational number, we got again an irrational number, right? Similarly, we can see the example like of multiplication also. If we multiply a rational number with an irrational number, the rational number is 2, irrational number is root 3. If we are multiplying this number, we will get it as 2 root 3, right? Which is again an irrational number, right? So these are the operations we can put on real numbers. Now let's have an example to check if 7 root 5, let's say, let me write here the examples. 7 root 5 is it an irrational number or not? Okay. Is it an irrational? So how we are going to deal with this? How can we check whether it is an irrational or not? Simply, we will find the decimal expansion of root 5. Firstly, we see the decimal expansion of root 5, which is 2.236 and so on. Okay. So since we can see that root 5's expansion is again non-terminating, non-recurring decimal, so this is an irrational number. Okay. Whenever we are asked to check whether it is an irrational number or rational number, we will just see the irrational part, expansion of irrational part, and then multiply it by whatever operation would be given there. We will do that only. So since here it is 7 multiplied by root 5, so we will multiply this entire 7 with 2.236 so on. So we will see that it is again non-terminating, non-recurring, so it is an irrational number. Alright, let's move further and have another example. Now if we are asked to add two irrational number, how we are going to deal with that? Since let me write here the example for you. If we are asked to add two irrational numbers such as 2 root 2 and 5 root 3. Okay. So to add these two numbers, the first number is this, and you need to add this number with another number which is, let me write here in a bracket. So the another number is root 2 minus 3 root 3. Okay. So many of the people would have a query in this part that this first number already is having two parts in it, right? But since we cannot add two irrational number in the same manner we do add rational numbers, so this whole is one number, one irrational number. Okay, and the second one is again the whole 2 minus 3 root 3 is an irrational number, and we are going to add these two numbers in our next slide, which is here. So how are we going to do it? Firstly, we will add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. So can we add 2 root 2 plus 5 root 3 plus root 2 minus 3 root 3 in a whole? No, because these all are having irrational terms in them. So first we will be doing it like, firstly it would be, let me write in a bracket 2 root 2 plus 5 root 3 plus the second number root 2 minus 3 root 3. Okay. Now we will see from here that the terms which are containing root 2 are 2 root 2 and root 2. So we can see here that there are 2 root 2 here and 1 root 2 here. And if we do add them, we will get how many times root 2? It would be 3 root 2. Right? The similar way, we do add terms in constant and variable like 2x plus 3x equals to 5x. Similarly, we have added here 2 root 2 plus root 2 is 3 root 2. And similarly, we can see again the terms which are containing root 3 are 5 root 3 and minus 3 root 3. 5 root 3 minus 3 root 3 is equal to 2 root 3. Right? Similarly, how we do add or subtract expressions like 5x minus 3x would be equal to 2x. Similarly, we have done here 5 root 3 minus 3 root 3 is 2 root 3. Okay. So when we added these two numbers, we got finally our answer as 3 root 2 plus 2 root 3, or we can say 2 root 3 plus 3 root 2. Right? Similarly, in this example, we did addition. Similarly, we can do subtraction also, multiplication also, and division also. Let's do one example of each part. If we are supposed to subtract these two numbers, like 2 root 2 plus 5 root 3, root 2 plus 5 root 3, the first number minus the second number, which is root 2 minus 3 root 3. So in this case, what we will be doing? Firstly, we will open the brackets and put the sign as it would have. So 2 root 2 plus 5 root 3 minus root 2 and minus multiplied by minus is plus, so it would be plus root 3. So in subtraction, we will get 2 root 2 minus root 2. 2 root 2 minus root 2 would be equal to root 2. Right? And 5 root 2, sorry, it is 5 root 3. 5 root 3 plus root 3 is equal to 6 root 3. So it is equal to root 2 plus 6 root 3. The answer is different from addition because we have done here subtraction. So these two operations we applied here, addition and subtraction. Now let's do another example of multiplication in this part. Suppose you are asked to multiply 6 root 5 with 2 root 5. Okay. Okay. So when you multiply these two numbers, firstly multiply the rational terms. 6 times 2. 6 times 2 is how much? We know 6 times 2 is 12. Right? Now we need to do root 5 times root 5. So root 5 times root 5 is 5. So it is 12 times 5, and 12 times 5 is, we know from 12 times table, 12 times 5 is 60. So here we multiplied two irrational terms and we got outcome as a rational term. Right, students? I hope this is all clear to you. Now let's do an example of division part also. So let's divide 8 root 15 by 2 root 3. So how can you do this? How would you proceed for this? We can write 8 as 2 times 2 times 2. Right, and we can write root 15 as root 3 times root 5. Okay. Now, if you write it in this, it will be 2 times and it is divided by 2 root 3, right? The similar terms in the numerator and denominator get cancelled out. So root 3 is cancelled out by root 3 in denominator, and 2 from numerator is cancelled from 2 from denominator, and what is left over is 2 times 2, which is 4, and root 5. So it is 4 root 5 which is left over, and which is our answer. Okay. I hope this is also clear to you. Now, what do we do to solve irrational number in order to get an answer as a rational number? Let's say if you are asked to 2 plus root 3 times 5 plus root 7, okay? But you are asked to write here the answer in the simpler form. So what you will be doing here is the second part of our today's lesson. The second topic which we are going to learn in this session is rationalizing. Right? So if in order to write the answer in the simplified form, what we will be doing is rationalizing. And how can you rationalize? What we do while rationalizing, we will see the sign here. Here it is addition, and here again it is addition. So if addition is there, we will be doing multiply and divisioning of the same number with opposite sign. Let's say to simplify 2 plus root 3, what we will be doing? It's a simple trick that if you need to simplify this 2 plus root 3, what we will be doing? You will just multiply and divide this number by 2 minus root 3. Okay. Okay. What happened to this when you do multiply and divide by same number? What do we get? See, when we multiply and divide by same number, we will just multiplying it by 1 because similar terms get vanished. So we are just multiplying it 1, and we are writing this 1 as 2 minus root 3 by 2 minus root 3. And you know an identity that a plus b into a minus b is a square minus b square. So here it would be 2 square minus root 3 square. Divided by 2 minus root 3. Okay. And further simplifying, what we will be getting, it is 4 minus 3, which is 1, divided by 2 minus root 3. The first term is simplified. Now let's simplify the second one. And the second one is 5 plus root 7. So 5 plus root 7 would be multiplied and divided by 5 plus root 7 would be multiplied and divided by 5 minus root 7. Since this plus sign is here, we will multiply and divide it by minus sign term, which is 5 minus root 7. Okay. Now again, a plus b times a minus b is a square minus b square. So here it is 5 square, which is 25, minus root 7 square, which is equal to 7. 25 minus 7 divided by 5 minus root 7. Okay. And is equal to okay. So it is the answer of and it is called as rationalizing. Let me give you another example to solve. If you are supposed to do rationalize the denominator of a term of a number which is 1 upon 2 minus root 3. What you will be doing, since we are supposed to rationalize the denominator part, right? So what you will be doing here, we will be multiplying and dividing the number with 2 plus root 3, since the sign is minus here. So it is, while simplifying, we will get the numerator as 2 plus root 3. And divided by a minus b times a plus b, which is a square minus b square. 4 minus 3 is equal to 1. So our answer in this case would be equal to 2 plus root 3 only. Okay. And we are done with the rationalizing part. Right. Now let's move to the third subtopic of today's lesson, which is laws of exponent for real numbers. What are the laws of exponents for real numbers? Do you have any idea? And do you remember how we simplified the terms in our previous lectures, like 17 square times 17 to the power 5? Let me write. If you were asked to simplify the terms like 17 square times 17 to the power 5, how would you have done this? Would you be first squaring 17, then cubing, then doing it 4 times, then 5 times, multiplying it for the 4 times, 5 times? Would you doing it? No, we are having some tricks to do it, and which that tricks are called as laws of exponents for real numbers. And the tricks basically are, see, we have some examples of to follow the tricks, and we have some examples, we have some laws, and those laws are actually, if you are having a number a to the power n, a is a number and n is a power of it, and you need to multiply it with another number a with power m. So in, since you can say that the number are same but the powers are different, right? So what you will be doing, you will just follow a simple law of exponent here, which is the same number as it is again to the power n plus m. When the number is same and you are having multiplication, then you will just add the powers. Okay, this is the first law. The second law is, if you are having a number a which is first having some power square, and again the whole is having some power 8, suppose, what you will be doing in this case? Let's write it in the form of m and n. Okay, so a to the power n is again having, the whole is having power m. So in this case, what you will be doing, you will see that the number is, the same number is having two powers, so you will be doing a to the power mn, that means m times n. Okay, right? Now we have learned two laws of exponents. The first one was, if the base is same and powers are different and you are doing multiplying it, then you will just add the powers. If you are having base same and you are having two different powers, then you will just multiply the powers of that number. The third law of exponent is, the third law here would be for division. Okay, so if you are having numbers a to the power m divided by a to the power n, so are you going to uh, do it multiply a for the m times or n times and going to divide it? Is it possible, or would you like to do this lengthy process for many times? I really don't want to do this. And for this, I have another trick, another law of exponent, which is same as the law of exponent for multiplying. It is a to the power m minus n. Okay? Because while multiplying you will add, you can simply remember that while multiplying you can add the parts, while division you can subtract the parts. That's a simple trick. It's really very simple, right? So this is the third law of exponent. Now let's move to the next law of exponent, which is, if you are having powers same, let's say you are having a to the power m times b to the power m, right? In this case, what you will be doing, you can see that the numbers are different but power is same. In the first case, what we saw? We saw that the numbers are same but the powers are different. So we just added the powers. Here the numbers are different and the powers are same. What you can do? You can simply multiply the two numbers which are different. A times B is AB. Okay. And the whole AB is having power as M. Okay. So these are the 4 laws of exponents and you can do some practice for this. Let me give you some example. If you want to find 64 to the power 1 by 2, what you will be doing? Would you do it? Would you do the power of it for half? Is it possible for you to do it manually? What you can do, you already know that 64 is just the square of 8, right? So you can write here 8 to the power 2 and which whole is having a power 1 by 2. And you know from the laws of exponents that if you are having the powers here it is. If a is having power n and the whole a to the power n is having power m, what you can do? You can simply multiply the powers, right? And here also you can see it is 8 to the power 2 and the whole 8 to the power 2 is again having power 1 by 2. So you can simply multiply the powers, which is 8 to the power 2 times 1 by 2, right? Right? And 2 times 1 by 2 is 1. So the answer here would be 8 to the power 1, which is 8 itself. It's so simple, right? Similarly, you can find 32 to the power 1 by 5, 125 to the power 1 by 3, 9 to the power 3 by 2, and many more. So these are just the examples of laws of exponents. Okay. So let's summarize, since we are done with the whole number system chapter of class 9. Let's summarize what we learned in this chapter. In this chapter, we studied a number r is called a rational number if it can be written in the form of p by q, where p and q are integers and q is not equals to 0. We learned the definition of irrational number also. A number is called as irrational number if it cannot be written in the form of p by q, where p and q are integers and q is not equals to 0. Right? Then we learned the decimal expansion of rational number. They are either terminating or non-terminating. They are recurring or non-recurring. Moreover, a number whose decimal expansion is terminating or non-terminating recurring is rational. Okay. Then we studied the decimal expansion of irrational number is non-terminating, non-recurring, and a number whose decimal expansion is non-terminating, non-recurring is irrational. Okay, so this is vice versa. Now the next point which we learned in this chapter is all the rational and irrational number made up of the collection of real numbers. They all comes under the subdomain real numbers. Okay. And after that, there is a unique real number corresponding to every point on the number line. Okay. Wherever we in the number line we can see a real number is unique at all the point. Also, corresponding to each real number, there is a unique point on the number line. For any real number, you will have another unique point on the number line. Okay. So this concept also we studied in our last lecture of the same topic. Okay. After that, if r is a rational number and s is an irrational number, then r plus s and s minus r are irrational numbers, and rs and r divided by s are irrational numbers for r is not equals to 0. So this concept we learned in today's class, that whenever we apply operation on rational and irrational number, we are getting some different numbers. Sometimes we get irrational number, sometimes we get rational number again, right? For positive real numbers a, b, we have some identities as root over a times b is equal to root over a times root over b. Okay, let me write here for you the identities for some real numbers a and b, that a times root a times root b is equal to root of ab. Okay, also root of a divided by root of b is the whole root of a by b. Okay, the next identities are root a plus root b, which we used so many times in today's session. Root a minus root b into root a plus root b. So what we can see, that a plus b minus a minus b is having an identity, that a square minus b square. So here a is root a whole square minus root b whole square. Okay. Is it? Yes. So it is equal to a minus b. Next is if we have root a plus root b whole square, so it will just be the same identity as a plus b whole square, that a square, which is root a here, a square plus b square plus 2ab.